Welcome to everybody online, wherever you are in the world. So good morning, good evening, good night, good afternoon. We welcome you to one of our new webinar series during the centenary year, the 100 years of ISTA celebrations. We started with one, which was a welcome and the starting of our president. And we'll have a number of events and webinars going through the year. Today it is about ISTA rules and vigor testing, and we always try to have people there who are longer in the association and people who are younger in the association. And we welcome today Steve Jones, who is a member of the ISTA Executive Committee, and immediate past president, Alison Powell, who is not only chair of the Vigour Committee and vice chair of the SSAG, but also an honorary life member of the association, and Yi-Cheng Chen from Taiwan, who is a member of the Vigour Committee. I would like now to start this webinar on rules and vigor, and ask Steve Jones to start with his first presentation. So Steve, as immediate past president and formerly at CFIA and in a previous career also in NIAP, where we will be in July for the 100 years annual meeting.
Can you see my screen okay, Andreas?
Yes, we can.
So today I just wanted to welcome everybody and give them a brief history of the ISTA rules, starting in 1931 with the first edition of the rules. And then I'll take you through some of the time when I was ISTA rules chair. But today we're going to focus particularly on vigor testing in the rules, as this then links through to Alison and Alison and the others in the meeting. So I'll just move something here so that I can see my screen. And then so in 1931, the ISTA rules were first introduced, and in 1954, tree seeds were added to the ISTA rules, and also to the at that time there was a big debate about whether the germination was in soil, or whether it was normals or abnormals that were counted as germination. And this debate also brought about the idea of the vigor discussions. And this is why today we're going to focus on that. In 2001, at the ISTA Congress in Angers, that was my first meeting there as the ISTA rules chair. And at that meeting, there was a large debate about adding vigor to the rules. At that meeting, I thought I had 3 years to actually work on the ISTA rules in between. But then at that meeting, they decided that there would be an annual meeting every year. So in 2002, we had our first annual meeting in Santa Cruz, Bolivia. And then I continued with the ISTA rules until 2018, when I handed that over to Ernest Allen. Over that period of time, the ISTA rules continued to develop, and we added GMO testing as a chapter and mixtures as a chapter. Since 2001, we became annual updates to the ISTA rules. Those annual updates were first of all hard-bound, spiral-bound copies, and then became a loose leaf folder for easier updates, but we were still printing them. It wasn't until 2014 that we had a electronic version, and then the different layers and annual changes were translated into French, German, and then later Spanish. The official languages of ISTA had always been French and German, and with the primary one being English. And then we've added the Spanish for the rest of the continent that's involved Spanish-speaking peoples. Over the period 2004 to 2008, we actually merged what were the white-coloured pages of the rules with the brown-coloured annexes. The main reason for doing that was that as QA came along, there were many more questions about what were the rules, what was part of the rules, and many of the clarifications and changes that have happened over the years have been to improve that clarity, to allow the labs to know what is a must-do, and for the auditors to know how they would audit the different people. We've also made different chapters of the rules available to end users. Some for free, like the chapters 1 on certificates to help organizations like OECD and have a harmonized approach to the use for sampling. That's why chapter 2 is free to everybody. Seed health methods are also free. By 2018, the test methods included 869 species. 13 species have been added since 2000, and there's still more to come, as there's an emphasis on adding tropical and subtropical species now. In 1931, we actually started with just 41 species of agricultural species. Many of the chapters were the same as they are today, and there was always the emphasis on sampling in the ISTA rules. The reminder to people is that there's no standards in the ISTA rules, but they're all internationally agreed standard methods, voted on by the government and distinct economies designated voting members who vote on the rules, in many occasions holding up their green or every now and again their red cards as a no vote at the OGM. Vigor test methods, as an example, we're focusing on that. There have been many other improvements over the last 90 years or more of the ISTA rules, starting in 1931. But with the example of vigor testing, that was added from vote in 2001 and became effective for 2002. And what that gave the ISTA membership and the rest of the world were ISTA standard methods, not company methods that may not be, the details of which may not be available to everybody. The ISTA method validation process was also formalized and became more of a formal document from 2007. It had been going on since the start of ISTA with referee tests and scientific data to help make decisions within the rules voted on by the experts from the different governmental labs at the time. Ever since 1924, even before they had the rules published, ISTA wanted to aim for uniformity in testing. The rules combined with the ISTA accreditation standard, the PTs and the auditing give ISTA that opportunity to develop and keep going in that same vein. So ISTA into the next century. Alison and I-Chen are going to talk about the vigor aspects, but the international rules for seed testing are chaired by Ernest Allen now. He took over in 2018, and with Sue Alvarez as vice chair, we'll be presenting on the current changes to be voted on in July. And he will provide, in advance of that, he'll provide the ongoing preparations for that. The rules have continued to develop. They're available in the 4 languages. During Ernest's time, they've added the machine vision options for electronic certificates, as that's something else that's going to be voted on in July, and looking to add new tropical and subtropical species. There will be a rules pre-voting webinar session again this year, which Ernest will chair, and that should be coming available in June, so look out for that in your newsletter. And as I finish, I'd like to thank Jim Shepherd, Doug Ashton, Kevin Boyce, Simon Cooper, John Hampton, Craig McGill, Ernest Allen, who have helped me as either vice chairs or an editorial board. Some of those people are no longer with us, but we still remember them, and we also remember the many people over the 100 years of ISTA that have contributed to the rules and to the effective use of ISTA over the time. At the moment, that includes Vanessa Sutcliffe, who does the editorial side of the ISTA rules, Ernest as the current chair, and Sue Alvis as vice chair. Thanks to everybody, and at that point, I'll hand back to Andreas. Thank you.
Thank you very much, Steve, for that overview about the history of the rules and evolving areas of ISTA. If you have any questions in the audience, you may put them in the question and answer box, and we, allowing the time at the end, will answer a few of these questions. Others will be forwarded to everybody here, and they might come back, the panelists might come back with answers to you. It's also recorded, and it will be available on the ISTA YouTube channel. Now I hand over to Alison Powell. As I said, it's very complicated to keep everything up, what you're doing and what you were doing in ISTA. You were also a member of the executive committee before. You are chair of the Vigour committee and one of the persons who introduced Vigour into the ISTA rules as well, and vice chair and previous chair of the SSAG and member, honorary life member, still representing the University of Aberdeen. And I hand over to you, Alison, with the next presentation.
Thank you very much, Andreas. I hope.
Only get it into presenter mode, then everything should be fine. Maybe on the back left, back top from the beginning. It's not bringing us into the right mode. Now we have it.
Yeah, good. Right. Well, thank you. Hello, everybody. As Steve's just mentioned, Vigour was first accepted as a chapter into the ISTA rules in 2001. So we first appeared in print in 2002. And what I'm going to do today is just look at what we've done since then and what we hope to do in the future. Well, when Vigour first appeared in print, we had two Vigour tests, accelerated aging and electrical conductivity. Both tests had been used for some time. Accelerated aging in the States, and it's produced first in the 1960s, and the conductivity first developed in the UK in the 60s and used from the 1970s onwards by seed companies and seed testing stations. But having got just these two tests and now having a bigger chapter, we looked to move to develop new tests. And in our further test development, we base this on four main principles: that the test should have a sound theoretical background, it should be developed using commercial seed material, the results should have been shown to predict differences in vigour in the field, in the glasshouse or in storage, and the tests must be repeatable and reproducible. And along with these basic principles, we always kept in mind that the test should be straightforward, easy to apply in a testing lab, and economical. So I'd like first to just talk a little bit about this theoretical background on which all the tests have been based. And the main theoretical background to seed vigour is seed aging. And we can see the process of seed aging in the curve here, which we call the seed survival curve, which many of you may have seen before. So here we've got the normal germination of the seed lot and how it changes with time. And you can see that the germination remains high, declining a little bit before a very rapid fall. Now, if we put this line across here, which is the minimum germination for sale of commercial seeds, we can see that seed lots can occur at a number of positions on the initial slow decline. These three seed lots, A, B, and C, all have a high germination, but they differ in physiological age. A has only aged a little bit, B a bit more, and C is moving further towards the decline in germination. And it's these differences in physiological age which are at the basis of seed vigor. And this aging can occur on the plant before harvest, which we call weathering, during processing, storage, or during transport. Now, we use the different changes that occur during physiological aging as the basis of vigor tests. And if we look at those changes, the very first is membrane deterioration in living cells. And as they deteriorate and their integrity declines, solutes can leak out of the cells into water. As further deterioration takes place and dead tissue is produced, even more leakage occurs. And this increase in solute leakage is the basis of the conductivity test. With further aging, we get a reduction in enzyme activity, and we use the reduction in the dehydrogenase enzymes of respiration to reveal the reduction in living tissue with aging, the tetrazolium test. Reduced enzyme activity also leads to reduced respiration and reduced synthesis of macromolecules, therefore slower and less uniform germination, and the basis of the radical emergence test. And we can use all these changes together in two other tests, accelerated aging and controlled deterioration. The next stage in aging, of course, is the movement towards the production of chromosome aberrations and abnormal seedlings, and we move to germination test. So we have the basis of vigor and germination. Now, there is another aspect to this slower, less uniform germination. And we can see that in what we call the germination progress curve, where we look at the changes in radical emergence over the time of germination. And here we've got 3 seed lots of maize, 2 germinating very rapidly and 1 much more slowly. It's germinating more slowly because it's been aging. Also point out this period, what we call the lag period, which is the time before radical emergence begins. And you'll note that it's much longer in the aged seeds. Now, it's well known that in all seeds, there's a period before radical emerges when metabolic repair of any deterioration takes place. And in these aged seeds, there's greater deterioration. It will be lot C on our survival curve. Therefore, if there's more deterioration, you have to have a longer period to facilitate metabolic repair before radical emergence, and that radical emergence occurs later. And this involvement between repair in vigor and aging that we refer to the aging repair hypothesis for all vigor tests. So we've used this as the basis of our development vigor tests, and as a result, we've introduced new tests which have been validated using the method validation program. And with time, new species have been added to each test when test conditions have been established and further validation has been completed. So that now in the ISTA rules, we have accelerated aging still, conductivity, which has been extended to other grain legumes and to radish. We have controlled deterioration for brassica species, radical emergence for 5 different species, and the tetratolium test for soybean. But we now briefly turn to what we've been doing more recently, and also think partly beyond 2024. And that's work that's been done with the radical emergence test. And we know there's interest in using advanced technology, often to automate tests. So we've been looking at the automation of recognition and assessment of radical emergence through using image analysis. And we've used 2 methods of image analysis. The first using red, green, blue light. And we've got evidence here for cauliflower and also for 4 other Brassicaceae species. Now this just shows us the field emergence of the number of seed lots and the radical emergence assessed and counted using RGB image analysis. This is early emergence, this is final emergence. And you can see where high RE is identified using image analysis, you have higher early emergence and higher final emergence compared to when the image analysis identifies lower radical emergence. Here we've got the plug emergence, that's emergence in plugs in the glass house. Again, the RGB radical emergence assessment. This is early emergence, high emergence identified by high RE. This is the seedling size, high RE identifying those seeds that give you the higher seedling size. The second type of image analysis we've used is multispectral analysis using the videometer. And here again, we've got field emergence related to the automated radical emergence assessed using the videometer for cauliflower and cabbage. And you can see that for both species where the videometer has assessed radical emergence, and you have a high radical emergence, you have higher field emergence, that's higher vigor, than when the radical emergence is low and you've got lower vigor. So both these methods of image analysis are identifying the differences in radical emergence that relate to field emergence. This is a relationship that we've seen many times using manual assessments, and now we've shown that you can actually achieve the assessments using automation with image analysis. If we think beyond 2024, we're sometimes asked about molecular markers of vigor. And there's two areas of research which have potential for this. The first is proteomics, where work's been done using Arabidopsis thaliana, which has suggested that mRNAs, stored proteins, and de novo transcription all contribute to successful establishment. The other work has looked at repair during germination of Arabidopsis, and this has identified 2 ligases in repair pathways and 2 checkpoint kinases, which may activate checkpoints that stop or delay cell cycle progression, and therefore give the capacity for repair during this delay or cessation of the cell cycle. So are we likely to move on with molecular methods? Well, potential markers have been identified, but only in a model species, here in Arabidopsis, and some work using Medicago. No work has been done on crop species that differ in quality, and no relationships have been shown to a practical expression of vigor. So finally, I'd like to just look at where we've been and where we're going. Well, where have we been? Well, in the last 23 years, we've made good progress in introducing new vigor tests and adding new species to each. We've made progress towards automation using image analysis in the RE test, and this potential for using image analysis has been proved. We have strong faith in the radical emergence test for many species, because our publications and others show that radical emergence predicts vigor in at least 20 species. That's beyond those which are already validated, and these species come from crop, forage, and flower species. The other possibility for RE is that if you're using the same conditions for an RE test as you would use in a germination test, you could include an RE count at an early stage of the germination test, and in effect, get 2 tests for the price of 1. And what do we think about the future? Well, we'd like to add more species to the validated tests, and we currently have comparative tests completed for radical emergence for onion and brassica species, and we're also working on barley. We'd like to think about moving more towards automation and wonder if the conductivity test would be possible. Some of you may remember that it has been possible to measure the conductivity of 100 single seeds simultaneously. So this may suggest that it's possible to move to automation with our bulk tests. There's also the potential for molecular methods. although model species have identified this potential. So we need further research on crop species, commercial seed lots, and comparative tests. And this suggests to me that it would be good to have collaboration between scientists who have more of a molecular focus and those of us within ISTA who are applied seed scientists. So finally, I'd like to say thank you to the present Vigor Committee, who you can see here, and to all past members of the committee who have contributed to the work over the last 23 years. Must also thank all the ISTA laboratories who have willingly participated in the comparative test for validation. We wouldn't be able to validate tests without their participation. And finally, to the ISTA Secretariat for the excellent support that they provide to us all. Thank you very much.
Thank you very much, Alison. That was very informative, and even I learned something out of it. That is something to say. I hand over now to Yicheng Chen, who is member of your committee as we saw it, but he also represents the Taiwan Seed Improvement and Propagation Station, Council of Agriculture, which is, I think, our laboratory Taiwan 1, TW1. Welcome to the presentation here, Yicheng, and we are looking forward to your introduction here. I think you should have.
Okay.
Could we make Yicheng? Oh, now you are presenter, and you can go ahead.
Can you see my screen?
Perfect, looks perfect, Yicheng.
Okay. Okay, thank you for the introduction, Andreas. And good afternoon, good morning, good evening, and good night to all participants all over the world. It's my honor to participate in this webinar with Dr. Steve Jones and Dr. Edison Powell. Today, I would like to share the experience in vigor testing from different aspects that include the seed testing laboratory aspect, the research institute aspect, and then the personal career aspect. For the laboratory aspect, I am now taking charge as the quality manager of the official seed testing laboratory of Taiwan. The laboratory has deep connection with ISTA. It was established and became an ISTA member laboratory more than 60 years ago. Our laboratory also passed the ISTA audit and became an ISTA accredited laboratory more than 20 years. Because of the government reorganization, the seed testing laboratory was taken over from an administrative agency to current research institute, Taiwan Seed Improvement and Propagation Station. We passed the audit by remote because of the COVID pandemic. And until now, the seed testing laboratory in Taiwan takes 10,000 pieces of tests that include domestic and international tests per year. Let's move to the object of my institute. It's also related to seed vigor. Two accredited laboratories take charge for seed quality tests. One is the ISTA accredited laboratory, and another laboratory takes charge for seed phytosanitary and GMO detection. Seed and seedling supplying is another important object of TSIPS. We produce and proceed feed corn, soybean, and sorghum seed for farmers. The monitoring of seed quality is a main issue during seed supplying. Furthermore, we provide technical service and farmer education and training. And the seed vigor is one of the important topics that farmers are interested in. And for myself, I attend ISTA activities 11 years ago, and then my current work tasks provide a good opportunity to have close connections with ISTA. I had an oral presentation about image recognition technology on assisting seed germination in 32nd ISTA Congress in Hyderabad. Then I was invited to join the Vigor committee. I would like to thank Dr. Addison and the other Vigor committee members for accepting my application. During the participation of Vigor committee since 2019, my laboratory joined a radical emergence comparative test on brassica, and we found different vigor levels were showed on different seed lots of Brassica oleracea and the Brassica jonesea. And now I would also like to share some research related to seed vigor. This is a research program aimed to use image recognition technology assisting seedling evaluation for paddy seed. We compare the results between trend analyzer and machine vision in more than 7,000 seedling images. And the results shows that the image recognition technique shows high accuracy, precision, and recall compared with human eyes. And another research is on seed vigor is to establish the radical emergence testing condition for paddy seed. We also compare the result of field emergence tetrazoline tests and evaluate some breaking dormancy treatments. And the result also show high correlation between field emergence and the radical emergence. For the future expectation, first is from the research to practice, how to utilize the good research result to help high manpower demand seed testing work is a main problem. And I have an internship in Gene Bank of World Veg Center. They're also very interested in vigor testing for germplasm conservation. Second is addition of species of radical emergence and more testing procedures for other common cereal and vegetables such as the sorghum and the tomatoes that my station supply. And the third one is to meet the expectation, in my opinion, the connection between advanced technology and the vigor test that Dr. Addison mentioned before is very important. Thank you for your attention.
Thank you very much for your presentation. I see that we don't have. There is one thing coming out. Let me find my questions. It disappeared here on the screen. Here we go. Now the questions are coming in. We have from one person 2 points here. Digital copy is good, but is possible to share first page, book first page, soft copy every year? I don't know what that is about, probably about the rules. Continuation to earlier questions, a couple of years back, is the rules front page binder available in soft copy? Nowadays, it is not available on website. No, we are not sending out any pages or binders anymore because most of the laboratories are not using them. They use them as online versions, and if you are a laboratory, you also have a multi-user license. So from every computer in your laboratory, the ISTA rules could be viewed and checked. And we are not sending out any binders anymore. You can have either your own binders or prepare something what you need. We stopped shipping also out of the thing that we want to save not only cost, because you would have to pay for that, but it's also a green, our green footprint, which is important here. Someone couldn't hear us. That was noticed 18 minutes after we started. Did I see right that tetrazolium is only validated for soybeans? That is going to Alison probably.
Yes, tetrazolium is only validated as a Vigour test for soybean. He was particularly interested in that in South America, which is why it was everything was done through our Argentinian member of the committee. The interest would have to come in using it would have to come from somewhere. She herself accepts that the tetrazolium test isn't the easiest and most straightforward test to do as a Vigour test. So it's not one that somebody has to be interested in pursuing it before we would go anywhere with that.
Thank you for the great session on this important topic. That is good to hear. Here's another question. What about cold and cool test as Vigour test? Maybe Alison, that goes to you as well.
Right. Well, there are many cold tests used currently throughout the world, different tests used by different companies, different labs. There's no standard test. We have recently had interest from one country in having a standard test so that tests from other laboratories could be compared against an ISTA standard cold test. So we are actually at the present moment conducting a comparative test using 2 different cold tests and doing more field emergence trials to compare to the results of those cold tests. And if the field results correlate with the test results, we will be putting that forward as a rules proposal for a cold test for ISTA.
Thank you very much for that. Next question is, what is the correlation between radical emergence and germination test? We have a high radical emergence score, but this may not be translated to normal seedling in germination test.
Well, we usually find that if you do an early radical emergence count, that is highly correlated with the final normal germination, because the seeds that germinate early are usually the seeds that go on to produce a normal seedling. If you compare early germination with late germination, the probability is that the early germinators will produce normal seedlings and the late germinators are more likely to produce abnormal seedlings. So there's been a lot of research which has shown a high correlation between a radical emergence count taken early in the germination test and the final normal germination.
Thank you for that answer. And hello, I want to ask about how can I measure the radical emergence and if there's some photo to help me. Maybe Alison, you can answer that one as well.
Yes, but the radical emergence, the criteria for radical emergence depends on the species. It's sometimes just the appearance of the radicals through the seed coat, but more commonly the production of a 2 millimeter radical. And that is assessed by eye, not by magnification. And you become used to recognizing what 2 millimeters is. And many labs have developed their own ways of, I've seen people just coloring in the end of a very small toothpick for 2 millimeters. They compare that to the length of the radical. And after you've done that for a while, you get very used to recognizing what 2 millimeters is. We do have some photographs with the species that are validated, but not for all species we've been working on at the moment. But I'm sure with experience, you'd find you recognize them pretty quickly.
I try to find another question here for you. How do you deal with species that have dormancy?
Easily at the moment, we don't deal with species with dormancy. It is another question. We haven't worked with any species with dormancy so far. We did radical emergence with wheat, but it is specifically for cultivars that do not show dormancy. So it's a problem we haven't tackled.
Okay, it's going on here. What is your opinion about radical emergence testing for forest species? For instance, for pine, the germination test takes 28 days, and radical emergence would help to reduce the result time.
Yeah. Well, we've not worked with any tree species. I don't think it's likely that we will do, but I imagine it would any early germination, early radical emergence would relate to the final normal seedlings. But you have to work on deciding at what time you do a radical emergence count. This is one of the things that's just add to the time of developing any radical emergence test, because you have to germinate a number of seed lots, do regular counts, and see at what point you get differences between seed lots, what's the best time. So it's something you have to work on with individual species. And as I said, we aren't really preparing to tackle tree species at all at the moment. There's too many species for 15 people to work on.
What's radical emergence time for vegetables?
Vegetables? Which vegetable?
Yeah. No, it doesn't say.
No, I mean, we say we've worked radical emergence. We've got radish. We're doing brassica species and onion at the moment. Any of the vegetable species could well be a target for a radical emergence test. But as I said, there's a limit to the amount of work that 15 people can do, particularly when they're only working part-time for ISTA. And what I've said often to people who come to our workshops is that if you work with a particular species and find that you can see that there are clear differences in radical emergence, if you can relate those to field or glasshouse emergence and are prepared to share your information, contact the Vigor committee. And if your data is good, we'd be pleased to encourage you to start on a comparative test to move towards getting that species into the rules.
What is the standard for judging that one seed lot is better and the other is in ranking during conductivity?
Well, conductivity, in general, you can say a high conductivity is low vigor, a low conductivity is high vigor. We can't predict what will actually happen in the field because different countries have different field conditions, different climates. We can only say that high versus low vigor. And if you're using high vigor seed, you reduce the risk of a problem. It's really, conductivity helps you to manage risks. So you judge what your vigor is, high versus low. Low vigor, there's a greater risk of problems in the field if your field conditions aren't good.
Good. There are a number of other questions coming up, but I would say people are starting with maybe we can take one or two of these. What is the standard temperature for maize cold test? Is
I'll
there
be
one, or is that depending on the
No,
experience?
it depends on the people who are doing the test, whichever company is doing it, whichever lab's doing it. There isn't a standard. You will find in, say, AOSA rules, they'll give you a temperature. Often, I think often is 7 degrees, and then transfer to a higher temperature. But there isn't a specific standard temperature. That's something we're looking at with the two methods that we're currently using in a comparative test. We'll come up with a suggestion.
And how can I compare vigor and standard germination? Can I compare it at all?
Well, the only way you can compare it is if you have a range of seed lots and they've all got high germination, then look at the vigor result. And if there's the difference between the vigor will show you which of the high germinating seed lots is most likely to give you problems in the field. I don't quite understand how else you'd compare vigor and standard germination. Vigor will give you a bigger range of results than standard germination because it's revealing something extra which standard germination isn't telling you.
Right. And one last question here. Are there any suggested limits for the considered high conductivity or low, or is this species specific?
Well, it will be species specific in that the species we've used include the grain legumes and one brassica. So obviously radish, the one brassic that we have, gives a much lower conductivity than the grain legumes. And the grain legumes that I think the ones that we use, the maximum conductivity is probably around 50 microsiemens per gram. And then if you've got an extremely good seed lot, even with no hard seeds present, you could go down to 15. But it will still depend on species, whether you're talking about soybean or peas or green beans.
I have one last question here, which is probably interesting for the whole audience. It's a question, does ISTA have plans for a radical emergence workshop?
We've focused on radical emergence in several of our workshops in the past few years. We haven't got an immediate plan for a workshop, but if there is interest in them, we will certainly be happy to arrange one in the next year or so.
Yeah, maybe we can let people know that there are certain procedures to have these workshops. You should apply at the Secretariat or at the Vigour Committee, and you will find information on how to do that on the ISTA website. If you want to host these workshops, there are certain things which we would expect from a host, but no financial obligations. This should all be covered by the participation fee. So if you are willing to host a workshop, that would be something we could arrange, and together with the committee from the Secretariat and the Vigour Committee. And I know that the committee is always happy to do workshops, not once a week, but a few a year may be possible. So if you're looking for that, just go there and come back to us when you want to suggest to host a workshop.
If I could perhaps just add, it is helpful if a laboratory has some experience in vigor testing of some sort or other beforehand, rather than be completely new to it.
Exactly. Yep. Thank you for that comment. And I would like to ask all of the panelists again on the screen. We wanted to say goodbye, and you can view this series as others then also on the ISTA YouTube channel in a few days. Watch the ISTA newsletter, and as I said before, there will be a big number, and I have to say Steve is coordinating all these webinars for the centenary year, Steve, you may want to say a few words to that as well. What is planned and what is coming up next?
Okay. Can you hear me now? Okay.
Yes, we can.
Okay. Yeah. So over this centenary celebration year, we're focusing on a number of different topics, making use of people like Alison, very experienced in an area, and involving people that are newer to an area to give an idea of how they became involved in ISTA and encourage other people to become involved. We have sessions that are going to look at, hopefully look at GMO testing, variety testing, also the science behind this and new technologies amongst others. We also hope to have some sessions on aimed at seed certification. So yeah, keep an eye out using the ISTA newsletter. Joanna, who's behind the scenes here preparing all that for everybody, we'll let you know, a month or more before the sessions are planned, and we hope to have good participation and also involve other people in presenting during the year. So thank you very much to Alison and I Chen for joining me on this one, which is the kind of the second one in the series. The first one was the start of the 100 years celebrations with Kashavulu and Ernest starting off the year, and this is the first kind of technical one following on from that. So hopefully the audience has enjoyed what we had to say, and we can have further participation in the future. Thanks very much, Andreas.
Thank you to all of you, and goodbye to everybody, and we will see in the next
Bye.
webinar.
Thanks
Bye-bye.
very much, Alison. Thanks, Chen. Bye, Andreas. Bye.
Bye.